each second, how much does the speedometer increase?
It goes up 5, 15, 20.
That's the odometer, right? But
Yeah.
what's the speedometer doing? After 1 second, if I drop a rock
10.
and it accelerates at 10 meters per second, right? After 1 second, how fast is it going? 10 meters per second, right? So after 2 seconds, how fast is it going? 20, right? It's increasing by 10 each time. That's what acceleration is. It's how the velocity changes over time. So the increase in speed per second, right, is our acceleration. It's that 10 meters per second per second. So increase in speed per second, acceleration. The distance fallen increases as the square of what? So if we look at that distance equation, right? Distance is 1/2 gt squared, right? So what's squared in that equation? T, time, right? Right, Abe?
Yes, sir.
If it takes 7 seconds, right? This was sort of that extender problem, right? If we had another stopwatch down here, you had to do the math, right? So if 7 seconds to reach the ground, then it's speed at impact, right? What's the speed at What's its speed at impact, right? After 7 seconds, the velocity is acceleration times the time, right? Acceleration is 10 meters per second, and our time is 7 seconds. So I have V equals AT, that equals 10 times 7. So my velocity is 70 meters per second.
Awesome.
Right? So 70 meters per second. Total distance fallen. How would I do that? How did I get 245 for that?
Times together? Times 70 and 10?
7 seconds, right? I've got my time, and I've got my acceleration still. What equation did I use to find distance?
D half AT squared?
1/2 AT squared, right? So if I have 1/2 AT squared, right? You guys see that? 1/2 AT squared, 1/2 times 10 times my 7 seconds squared, right?
Okay. So, well, no, I might have some.
So what's 7 squared?
Another.
49. What's 1/2 of 10? 5. So 5 times 49 is 245, right? So my distance fallen after 7 seconds would be 245. What's my units? Meters.
Yeah.
Acceleration of the fall just before impact. So this is sort of one of those tricky questions, right? Just before impact, what's the acceleration?
10.
Why do you say that? Just before impact, right? It's always 10, right? Free fall. It's still 10. Always. Until it hits the ground, right? It's going to be 10. So that's the idea behind that. Go ahead and check your answers on this. If we open up to page 43 in the course pack, we've got some free fall practice. Some of the same ideas, right? V equals AT, V equals 1/2 AT squared, right? We've got 2 equations now that we need to practice using for these problems. The first part is basically to fill out a chart that essentially, some of you may realize, is very, very similar to what we've done on this worksheet, right? Page 43. I think it says free fall right on the top. But essentially what we did with this worksheet is very, very similar to the first part of that of page 43. It's essentially a table. They want you to, for a freely falling object,